Okay, amazing. Hello, everyone, and welcome to the February 8th afternoon PST, morning Japan, early evening East Coast time overview of the Everywhere Computer. My name is Boris Mann. I'm one of the founders of Fission, who are the builders of Everywhere Computer. Brooklyn Zelenka is my co-founder and CTO. We've got Ryan, head of product design and various other tasks. And Chad, our head of operations, with us today. Purpose of this is to basically do an overview of what we're working on with Everywhere Computer. Feel free to ask questions as we go. You can either use the chat or go ahead and unmute yourself and ask the question live. Totally not a problem either way. And then we'll pause a couple of times for folks that have questions. And actually, do one more thing here. Brooke, I will make you a co-host in case there's any other button pressing. Okay, Everywhere Computer. What is the Everywhere Computer? Fission has been working on a set of protocols around identity, data, and compute for several years now. All of this to make it much easier for developers to make applications and get them all the way to launched and running, without having to do a full stack set of layers that you have to learn and deploy, and without having to learn a lot of DevOps along the way. So what the Everywhere Computer is a network of functions and computation with payment included. So you can run your own node or portion of the Everywhere Computer on your own desktop, or you can rent computation from the network. So just like you might pay Amazon or Azure or Google for cloud functions, you can in fact pay the network or connect with friends and essentially have friends do computation for you. We see this as being all written in WebAssembly. So WebAssembly is the newest part of the web stack, and a very portable and secure way of writing applications. You can write them in Rust, JavaScript, and eventually like other programming languages that compile down to WebAssembly. And then finally, UCAN is our decentralized auth system. Much like Amazon has their identity and access management layer, as do other like large proprietary systems, we see UCAN as an open and extensible protocol that you can plug in web services and without having to be in just one system. Lot going on this slide. This is to explain the different layers of what we're doing. So the Everywhere Computer is really the platform that Fission is working on. All of the protocols that we are open specifications that have been developed alongside of community members. And the source code implementations are all under open source licenses. And we're plugging this together into a platform we call the Everywhere Computer. Homestar is the Rust compute node. So it's the one that you can install, and I'll show a demo of on your desktop, and it will run these WASM functions locally on your computer or anywhere that it is installed. And it will also handle basically figuring out where computation should go. And then as well as just code, this is the interplanetary virtual machine. So that's the protocol. So just like HTTP is the standard protocol for browsers, IPVM is a way to do computation and ask different actors to invoke computation. And so over time, we see other implementations other than Homestar. There's a list of folks there, some of whom participated in the design of the protocol. We had a really good call with Filecoin Station. So they have about 10,000 desktop nodes. That's probably not an area that's going to be heavy focus for us. But if they want to run compatible functions, they could add that functionality and then all of a sudden get access to all of the functions and features of the IPVM and the everywhere computer. Um, what we have running so far, we have a visual control panel. That's at control.everywhere.computer. And while it is published and hosted by us, it actually connects to and talks to your local node. And it may have other features over time, such as, helping you control clusters or other things like that. Um, Inside of that, we've got a very basic set of functions. So again, imagine something like npm and JavaScript. We know that there's hundreds of thousands of JavaScript functions, and the way that most front-end development gets done today, people don't write all of the JavaScript from scratch. They, in fact, compose it and find different frameworks and functions that they use, and then do their specific application and business logic. We're originally going to kind of curate the functions. And we have just a couple essentially demo ones in there right now. And anyone will be able to curate and run a registry of functions, or you can just publish them onto IPFS and use a content address, which also makes it very certain that you're using the function that you wanted to use, regardless of things like versions and things like that. And then finally, Homestar. So you run that on your desktop. Again, much like you might run a sample server or other things like that. You run it, you work with the functions you're doing, you test some things out, and that's fully functional, but also part of a developer experience where you're building and testing the things that you're working on. This is something that I've added where just to talk through. So we have functions. Functions are technically a WASM module that has a set of code that is being compiled to a WASM module that has one or more functions inside of it. And that module would get uploaded to a registry, so those functions are available. Tasks are roughly a function plus parameters or resources needed. So an image and crop sizes. And you can see that in the screenshot, and we'll show that live in a second. And then a workflow is really a series of tasks. And the way that Homestar works is both tasks and workflows, as they're done by the network, they're cached. So if you're connected to a wider Homestar network in the everywhere computer, then any function or workflow that someone calls a second time with the same arguments doesn't need to be computed. It just will run by looking at the receipt of the stuff that's done, which is a pretty interesting feature. I will pause there for a second before switching over to the live demo. Any questions? And I know that was a speed run. Awesome. So this is a screenshot of the everywhere computer control panel. This is all in our docs, and you can follow these same steps later on your own. I'm not going to go through all of them from scratch, but use some things that I've already got running in the background. And the place to get started for code is a few settings in this getting started repo. And then does everyone see that docs page? Amazing. I've done a number of these things already. Clone the getting started repo. I've got IPFS desktop running. So I actually have a local IPFS node, just like we're going to have a local compute node. I've generated a key pair. And what I'm actually going to do now is I'm going to copy this code. You won't see this because I'm going off screen to my terminal. I'm going to paste that in, and it should be up and running. And then it's telling me to go to the control panel. Here is the control panel. Shows a little green icon there for a moment there that said that it's connected. I had this cached already, so sometimes I need to just hard refresh. Just do that now. Don't ask me why I have a 190% total system load. I have a lot of tabs open. That could be the reason. It's showing that it's not actually connected to anything else right now. So I'm going to be running it in just single user mode and do some workflows. So clicking over to the workflow, I will do this. So what we have done, each of these are functions, like I said before, with arguments or parameters inside of it. And the first task is actually asking for an image upload, and this whole thing is a workflow. We chose to do a visual builder like this because it demos well. What we'll be working on is basically more tools for developers to be able to essentially look at the workflow settings files themselves and compose those workflows. But this gets a sense of how these things run in the system. So I'll go ahead and pick an image to upload. I think I had some Fission. Yes, let's use, oh no, that's 23 megs. Let's not do a 23 meg file. Let's use our friendly RSUCAN mascot, the crab. So this was waiting for an argument that is the actual source of the image. Underneath, it'll get content address and plugged into the workflow. I'll go ahead and run it. This is not very hard to do. This is a small image. It has cropped it to a tiny piece, and then it has blurred that. What you see down here is a receipt. So that is the receipt for the entire workflow. So if we need to do a crop or we need to do a blur, that'll actually be in the system if I start with the same image. I'll go to the sample one. So this is rotate in grayscale, which is again, and in our last workflow, we had crop and blur. So neither one of these were applied. And if I go ahead and hit run, it'll run and rotate and grayscale. And again, if image processing as an example is fairly easy to understand. If other people were cropping or rotating or do anything with this image, the system would be cached and it could immediately serve it back from there. Workflow 3, this is going to do a blur and a rotate. I might almost, blur sometimes takes a little while. Go ahead and just run it. So this is the part where I always think, is the demo broken? Oh God, is this going to work? Am I going to be surprised, disappointed? And success. Come on, rotate. You can do it. There we go. So blur ends up being a computationally expensive kind of thing. You saw in comparison to the other two that actually took a while. So what we're going to do now, just to show, so this was blur and then rotate 90, right? So we're going to actually create a new workflow. Here's that blur function already preloaded that we did before. And then I'll add another one. So rotate 90 would be the same one that we already did. So we'll do that different. We'll like grayscale it and then rotate 90. And I'll again use the same image. So what's going to happen now? Remember that last function started with blur. And it actually took a while because I had to do a bunch of explaining and it showed that it was running. And what we would expect to see, if this is working correctly, is that it has cached the results of the blur. So it will complete very quickly. First of all, I need to save new workflow 6. And then I need to go back into it. And I love this visual twiddler so much. I'm going to go ahead and hit run. Boom. So we've signified that this actually got from cache rather than taking a long time like the previous one with the same image did. It didn't have to be computed at all, and it was all done locally. Imagine with a larger network, you'd have more receipts, and this could be basically a speed up computation for the network by pulling it from cache. And that is the end of the live demo. Do you guys have any questions about this interface or what's going on underneath the covers? Thanks, Jane. Uh, I stop sharing this, and I will head back over to our slide deck. Again, went through that pretty quickly, but that's a good example of the types of things that you can do in kind of caching computation that you're running locally from your own machine. I thought I'd switch things up from our January call and talk about some new stuff. Gotta love the pink. So another little bit of a complicated slide. So right now, what I just showed you is essentially the developer desktop demo. It's connected to the control panel so that we have a visual interface for, and this is obviously talking very locally, right? It's using a local port with localhost to connect to the node that's actually running on my machine. And yeah, so I'll talk about that on this slide. We have been working on, we use libp2p as a peer-to-peer connection method. And Homestar is now able to connect to other Homestar nodes. Brooke, do you want to just tell us a little bit about what the star configuration, what the state of that is?
Sure. So in the ideal state, or even the end state of where we're going, any node will be able to connect to any other node automatically, regardless of where it's sitting. Like if it's a home machine or up in the cloud, or any of these things. But if you're on a, you know, sitting on consumer Wi-Fi, you have a NAT in between, so you're not dialable. People can't call into you. You can only call out into the network, which is a real problem for P2P systems. And doing NAT traversal is a hard problem, and we're working on it, and we're most of the way there. But we thought in the meantime, we can run one hosted node, or there could be an infinite number of them, but we're starting with one hosted node, and we can route messages through that, because you're basically dialing into a server and then it's passing those on as a proxy. So the technical term for this setup is a star topology, where you have one node that everything's getting routed through. So it looks like a single node in the middle with a bunch of rays coming off of it, hence like a star. And we're propagating everything right now through gossip. So that node will hear about a message. So you'll send it a message and say, hey, tell the rest of the network about this receipt. And it'll propagate that on to others. And there's a pub sub setup with that. So they can either accept or ignore messages depending on the topics they care about. So it's like, oh, I really want to hear about, image functions. So then those will get forwarded in to your particular node. The downside today is that it means that you have no way of discovering other nodes on the network, because you can't dial them directly. You have to go through some other node up in the cloud. The other way around this would be, if you have a static IP address, you could look that up, but we don't think people will actually do that. So we're working on figuring out what's called AutoNAT, and that'll be the actual solution. We have that working for like a subset of things. So we'll have a full solution for that in the next couple of weeks here.
Yeah. Awesome. Thank you, Brooke. Hello, newcomers. Feel free to ask questions as we go. I'm just talking through this slide and some of the new features that we've been working on for Everywhere Computer. So, with that ability to basically connect to other computers, we have been thinking about like how and why people want to connect in different ways. The terminology that we're working on is basically to have subnets. So one example that I put on here is that like your team subnet. This was literally until moments ago called Fission team subnet because that's our next task is that basically everyone on the Fission team and their home computers and desktops and this is my year of tiny hardware, so I've got little bits and pieces of things kicking around that we want to run Homestar on. That will have a setting to be able to connect to each other's machines and gossip the receipts from computation between it. Our goal generally will be to have a beta subnet that we not the final name because we like naming things and beta subnet sounds a little boring, but there will be something that sounds like a beta subnet that part of the onboarding as your individual developer desktop mode will be to register yourself and come onto the beta subnet and thinking about what those settings are. So what we've really seen in the wild and that kind of Fission's original mission is that we've got this stack of identity, data, and compute. And really none of them are something that you can skip. That's the stack that you need to build most anything. So a lot of the stuff that we work on works with IPFS. The IPFS mainnet, this is sort of emerging terminology, but it realized it was helpful, is called Amino. So basically, by default, if you've ever like booted up IPFS desktop at home, you're by default connecting to the Amino DHT. So that's one big global content address cloud. Again, depending on where you are and how you can connect to other machines, you may or may not be able to reach things, but it's all one big open network that you can read and write to. And we're aiming with the Everywhere computer to essentially have computation to that data piece of the IPFS mainnet. So WebAssembly functions can be published anywhere. Data sets can be published anywhere. You can host your own. You can go to a commercial IPFS hosting provider, and then you'll be able to feed those content addresses as resources to any compute that you want to do. This has some other benefits in routing and scheduling jobs in different ways. In basically, there'll be certain like agreed upon settings, such as we're going to connect to mainnet. We're going to have these functions available. That's something that we're actively interviewing people around and figuring out what the needs are. But that's kind of how we're thinking about it right now. DID accounts, Matt. Great question. So lots of different labels on here. So in the Everywhere computer, Fission runs an IPFS cluster. So anything that's published to our default publishing registry, we'll make sure it sticks around and stays online. DID accounts, decentralized identifiers. So those are from the standard from the W3C. We use those generally as user-owned accounts. There'll be a default set there with an attached email address. So this is not like a completely anonymous system, but it is a user-owned system, basically. Does that answer your question, Matt?
What DIDs get you is a verifiably unique identifier that you can prove you have control over, and then we can map a name to it, or you can map a name to it. So it gets at the system level, the uniqueness and the provability, while still giving you the ability to put a human readable name on it later.
Well, thanks.
Yeah, there's a few DIDs are the largest deployment in the world right now would be Blue Sky. So Blue Sky underneath, you own your account And if you look underneath, your ID is in fact a DID. And that's one of the ways that they're making a distributed system. We're big fans of a lot of that model of essentially use your own data. And this gives a lot of flexibility, basically. Great. Yeah. Chad just dropped a link to some DID stuff. That's a pretty deep start, but think of it as a unique portable identifier, which is a great start. Any other questions? Great. Thanks, Chad. Um, so some ideas around subnets. Um, I'm actually going to skip that first one and then just hand it to you, Ryan, because I put a couple of other ones on here. So right now, the way we're thinking about subnets is you've got some reason to work together with folks. So are there some data sets you'd like to keep online, or continuously publishing, and then have a number of functions for querying and transforming that data? Again, instead of everybody running things on separate servers, we can use content addressing to make data available everywhere. And then there's going to be a pretty standard set of functions for transforming from one thing to another. Actually, use an example. You have a Blue Sky post and you want to cross post it to Mastodon. That's an example of where you could write that function once, run it on Homestar, and then anyone can use that function. Imagine firing that all the time in a serverless system that you transform one into another, or transform Markdown to HTML, or vice versa, or other utility functions like that. And we think that every application or ecosystem will have a slightly different need of identity, data, and compute. So in some cases, you might, if you're an application developer, you might install on your client's machines some Homestar nodes as well, so that they're helping to compute the things that your application works with. We've been looking for like early use cases and ways to work on that. And with that, I will hand it over to Ryan to talk about Farcaster and frames.
Sweet. Do you want to pass over screen sharing quickly to me? Might be easier to explain
totally
some of this stuff with a visual aid. Okay, so we covered this a bit in the pre-recording preamble, but let's do it again. Farcaster, what is it? It is an open social protocol. So the clearest way to think about it is as an open social graph that can provide an alternative experience to things like Twitter and Reddit. The primary client on the protocol, Farcast, is called, protocol Farcaster is called Warpcast. So that's what I'm sharing here. The landing page for it. Y'all are urged to sign up and check it out. I believe there is a protocol layer fee to join for reasons we might get into later. But that's being sponsored for anyone living in one of 20 countries, which happens to include the US. Being sponsored by the company behind it. It's comparable to alternatives to Twitter like Blue Sky and Mastodon. The way to think about Farcaster and Warpcast, if you are familiar with the architecture of those other social networks, is Farcast is to Warpcast as app protocol is to Blue Sky, or ActivityPub is to Mastodon. It's worth mentioning that all the activity on the message or on the network, the content that you post, the social graph that you have, is gossiped around to, at the moment, I think roughly 250 or more hubs. And there's one part of that lives on a blockchain, which is your ID, just a unique number. You have some keys that control access to that. You can attest control of some other blockchain accounts. through that. Everything else that you do is gossiped. Why is it interesting? Obviously, at this moment in time, there's a lot of interest over ownership of your social graph, whether you are just somebody following current events or some interest that you have, or whether you're some kind of a content creator or other public figure of some degree who has a relationship to your audience. And you just want to make sure that you've kind of got access to that at all times. Slash, you can make these like cozy little corners in that space on your own that suit the needs of your own community, or you can dial the fire hose way up to max and just swim in the whole open ocean of information. This notion of signed authenticity of the origin of the content is pretty interesting, and compared to those alternatives, the app protocol and activity pub right now, there's a lot of excitement in the Farcaster community. For one, the release cadence of the team behind it is really, really high at the moment. And in the past month, growth has been ferocious, in large part due to frames. And so what are frames? Frames are little mini apps that can live in the feed. So unfortunately, I'm not signed into Farcaster on this window, but you can imagine Twitter, right? And for anyone here that might be familiar with open graph tags, the unfurled link previews that you see when you share a URL on any of those platforms, you'll end up with like a little rectangular image, right? What frames do is they take that meta tag standard called open graph, which you see right here, which the most critical tag, basically, or the most commonly experienced tag is the one that links to an image. And it adds some extra protocol specific tags that will enrich that open graph embed with some interactivity. So you get 4 buttons, you get up to 1 text input, and you get a little bit of control over the image that gets returned from a post URL that you can define. So over the past, it is worth mentioning that frames have been out now for like 10 days. And I won't explain or get into all of the stuff that's being done with them right now, but suffice it to say, the craziest one that I've seen so far is the whole Farcaster network playing Doom off of one person's computer. Lots of stuff that you wouldn't expect to be done through such a constrained experience is being done. And the reason that the team chose this is because of the very confined security model of like you're just passing images back and forth from a post. So over the past 10 days, we've put together a little boilerplate repo for quickly with no opinionated frameworks included, writing a frame that's ready to be launched to Netlify or with some modifications for Cell or anywhere else. And so here you can see me logged in as myself interacting with this frame that at the moment is just being served off of my local computer. And so you can build these nice little walled garden experiences. And so we're thinking that this is a really amazing fit for the capabilities of the everywhere computer at the moment, because it can very easily produce anything in the foreground, like the open graph images that you see returned, or even could be used to do kind of offline in the background data analysis on your social graph to provide some of the fodder for the business logic that drives the interactivity in this frame. People are also doing other things like minting NFTs directly from these frames, running 1 or 2 click e-commerce integrations, and The other security concern to mention that is like by default addressed, without getting into the weeds here, for anybody who's familiar with like the risks associated with blockchain associated public key pairs, is wherever it is that you keep your money in a account that you use on a day-to-day basis, or an account that you might store things in for the long haul, even if you've associated those with your Farcaster account, they are not connected to this frame. You have a separate intermediate key pair that is signing things on your behalf in here. And so you are not at risk necessarily of having stuff drained. But yeah, still early in the exploration of this. And once we have everywhere computer booted up and running mainnet, it'll be really fascinating to see what everyone builds with it.
Awesome. Thank you, Ryan. Do you want to hand the screen share back to me? Amazing. So basically the developer experience that we'd like to get to is exactly what we've got today, where you've got a Homestar running on your local machine. So instead of needing to publish to Amazon or Netlify or other things like that, you'd run Homestar and some functions in a CLI locally, and be able to like serve up an endpoint directly from your computer. And in fact, in some ways, what we're going to work on is like, yeah, if you close your computer lid, you turn your computer off, your frame won't work anymore. But that's, in fact, the path that we want to explain to people, that right now you're running in this mode where it's literally running on your machine rather than in some far off cloud. And the next step would be, well, if you publish those functions, then your subnet or other nodes in the network, we will be able to power those functions for you. And you in turn can power other people's functions. Which is a good segue into being like, okay, so I'm just going to contribute some compute. How is this going to work? So we talked a little bit about the account system before, and like a lot of systems today end up having like a freemium level or anything else like that. One of the big things that we've been really exploring and inspired by some of the writing that people have said, like, oh, I used Vercel or I used Replit, and then they changed all the pricing and it got really high and I can't afford it. Or I am literally in India. I literally don't have a credit card. I can no longer use your service. That really sucks because this worked really well for you. And that's because of the model of kind of subsidizing that compute in different ways, which we can't do either. But what we can do is say, like, no problem, bring your own server, and run it on your desktop, run it on your friend's desktop. I had a really interesting experience. In fact, I'm wearing a hoodie from Istanbul University that I went to, for a young man there who he's hacking on an app. And he's actually running that app from his laptop at home, because even in Turkey, they in fact have a 1 gigabit home connection. And we think that opens up some interesting things in there for people to do a lot of different options. What we do need to do is create payment channels. So basically say, WebAssembly, just like we saw that blur take a long time, that time would be extra computation. So we would need to meter how much computation your node is doing. And we're likely going to do something around points or credits. So, you basically, if you keep your machine running and you contribute computation, you'd be earning credits. And if you then close your laptop and you want the network to keep running your functions, you could use those credits. And the actually technical implementation of how the nodes would communicate to each other to do this is over to Brooke.
Okay, so payment channels. If you sort of squint at a lot of the stuff that we do at Fission, it's like, well, what if we took some stuff out of the blockchain world and applied it to like non-blockchain things? So payment channels are an old idea for doing peer-to-peer payments. We don't have to go back to the previous slide, but basically the problem that they solve is how can we transact without having to go through every single time through some central bank of some kind? What if I want to send somebody money and the network is down? We had a large telecom outage here back in September, and like nobody could buy coffee, right, for a number of hours, right? Problems like that. Also, how can we make them instant and really, really, really cheap, right? So basic idea is that we're going to create local first instant peer-to-peer payments that can do micropayments as well. So you can get it as small or as large on the channel as you like. And it's all implemented in UCAN, which is our auth layer that we mentioned earlier. And that also underlies all of the security for the function running, right? So that you know that you can actually run something on a certain machine or access some stuff. So there's a lot of stuff happening in this diagram. If we go to the next slide for us. To set up a payment channel, you and the person you're going to interact with lock some funds into some underlying layer. So that could be into a bank account, into a database. As I mentioned before, people have done this on blockchain. You can lock it into a blockchain. Doesn't really matter. And even the exact currency under there doesn't matter. Is it credits? Is it dollars? Is it a number of times, somebody watched the kids? Like it could be any of these things. It doesn't really matter. It's an abstraction of just points at the level of the channel. So you have to both put in, let's say we want to create a channel that's worth $100. We could each put in $50. Alex and Bob here could each put in $50, or it could be 20, 80. Doesn't really matter. We just have our starting funds. Next slide. Then when we put that in, what we get back is the initial state signed by that settlement layer. So it says, A, B, C, D, E, F. That's your proof that the balances are 50-50 right now. And then we can take that and write down, I'm going to update the balance to be 2080, and I'll sign it. And as soon as you countersign it, we agree that either of us could send that back to the settlement layer, but we don't have to. We can just keep updating that with new balances, as long as we keep information around that says this overrides that other one, right? And so, it says 80-20, then it says 70-30, and then it says 90-10, and then it says, 80-20 again, and, 40-60. And we haven't had to go through anybody else. We're doing this totally peer-to-peer at this point. Boris, I can't hear you.
Imagine running a subnet with your friends and settling up once a month. Or settling up daily, right? So there's a couple of different ways that you could do it, and then different subnets might actually have default settlement times or other things like that, right? Where you're like, yep, we'll trade it up just in the same way that a group of friends might be like, okay, you got this coffee, I'll get the next one. You're not having to go through any other system.
Yeah, exactly. And stay on the slide, for now. When you go to settle out, essentially you're saying, hey, I want you to update that balance and then pay, unlock the funds. There's always a risk, because this is totally peer-to-peer and a bunch of stuff has happened out of band, that somebody, Alice could say, aha, I'm going to submit a previous receipt where it looks much better for me, where I had 90 and, Bob had 10, even though it's actually now 40-60. So when you go to settle, it's either Bob has to agree to it and everything's released right away, or there's some, let's call it, a couple of days where Bob can submit a newer receipt that can prove, again, cryptographically, just with hashes, kind of like in your Git history, you can prove that this one came after those ones, that this is the latest version of the receipt. And if we go to slide 14 now, you probably don't want to set up a whole bunch of these, because you have to, that setup phase, locking funds in. That's the hard part, right? That part kind of, it's time consuming. Maybe you have to pay a fee, all of this stuff. So it'd be much better if you could then connect them. So here we have Alice, Bob, and Carol, and Alice wants to pay Carol. well, she could pay Bob $10 and Bob could pay Carol $10. And so you can add optionally onto this a routing layer as well. That way, you could have as many hops as you like, but 7 degrees of Kevin Bacon, right? You can get to basically everybody in the network very, very quickly.
Made it even easier if we constrain it by subnet or other things like this, right? So we're kind of this is early research on some of these things, but people have been asking about it. So thank you, Brooke, that we have an initial run at getting a recording of this that we can share with folks. Again, a lot of the goals of that is being able to run these things in a distributed network and actually keep track of things. Other things that we've seen in the past have been things like BitTorrent networks, where certain groups might have leech ratios, where they say like, yes, you can download this thing peer-to-peer, but we want you to seed it to the network. This is a similar concept, except applied to use of computational resources. The storage one is an interesting one too, with IPFS and persistence and other things like that. But it doesn't quite make as much sense to do in this way, because compute ends up being something a much heavier resource than keeping some files around. That is it for the overview of where things going. We try and do these every so often. We're available in our Discord. You can follow the docs, so all this stuff is live right now. I started with that getting started repo, and download that and then follow the instructions in the docs to get stuff up and running. It's early days for writing functions. Right now, if you are comfortable programming in Rust to WASM is quite good. We've got we're going to have some helpers to help those who are comfortable in JavaScript compile to WASM. We want these things to be available and published. So ideally, if you have an interesting function, it'll be usable by other people over time. Go ahead, Brooke.
Probably worth noting, just in case people go poke around with WASM and see that it's supported by a whole bunch of languages. So WebAssembly itself, like the base layer, compiles from I think like 60 languages or something. Any language that compiles to LLVM will compile to WASM. Because we have to deal with serialization and deserialization over the network, we need to have a little bit of extra type information and know how to do those conversions. So we're using part of the normal WASM specs, but it's still very early, called WebAssembly component model and WebAssembly interface types, which is why we are currently restricted to Rust, JS, Python, and assembly script. But as that gets more mature, we're going to obviously, actually, we don't have to do anything. Those tool chains will just automatically support that.
Is it actually abbreviated WCM or not?
Everybody calls it WASM components. Yeah, but WASM interface types are WIT. In fact, I believe even dot WIT files and things.
Amazing. I love real-time editing of slides, so I don't have to do them later. I will stop sharing that there. Questions, comments, we'd love to hear about your use cases or the kind of like, can you do X? Or I'm thinking of Y. If you've got any questions, the link is there as well. If you want to book time with Ryan and I, we'd love to do a product interview with you. Other questions? Amazing. Check the calendar. Like I said, we'll send an email with links to all of these things. And if you aren't already in the Fission Discord, we can do that. I'll stop recording, but stay on so that you can also ask questions off the record.